Let's see, get recording started again there, I think. Yeah. All right, so I just started here by putting up those two different formulas that we use to convert from one temperature system to the other. And if I'm giving, let's say, I'll make up something here, a Celsius temperature, and I want to turn it into the corresponding Fahrenheit temperature. If I started with Celsius, I want to end up with Fahrenheit. So I want to end up with the Fahrenheit. I'm going to use this formula so that, you know, whatever work I do just all adds up to the final answer I'm looking for. So then we start by plugging that number in. You kind of rewrite the formula and substitute in the number you're going to work with. There's the 9/5. I'm going to put in the 75 degrees. I'm going to kind of make it look like I'm right next to a fraction. So I tend to write it like that. So you kind of see how we're going to maybe even think about that as 75 over 1. And just because Fahrenheit's kind of weird, we're going to add 32 at the end, shift everything up 32 degrees. So start with what you have, plug it in for the appropriate letter, and now we do the work. This was 75 times that fraction, so you can do this in your calculator, but I could cancel some 5s here. That's a 15. And see, 9 times 15, 45, and carry a 4, 135 plus 32. I did that in my head, hope I did that correctly, but you can check your calculator. And now just to finish the addition, kind of following order of operations rules, right? I multiplied that part first. Now I'm going to add, and the temperature will be what, 167, right? Probably just right for green tea or something. I don't know. Make your meat at least 167 degrees. Yeah, too hot for outside. If I'm going the other way around, oh, let me get my erasing cloth here.
I have a question.
Pardon? Yeah.
Where did you get the 9 over 5?
Oh, I'm sorry, say again?
5.
Where did I get the 5?
The
No.
9 over the 5.
Oh, so these are our formulas. You might say that you're given to start with. This is the relationship between Celsius and Fahrenheit. So
okay,
you'd be given that. Like we'll see today, we have quite a few formulas that we use for our geometric quantities. This is a formula or relationship that we use that allows us to go back and forth. So I didn't pick it up.
Thank you. Yeah.
That's all right. Good. And going the other way around. So if I've got, say I've got a Fahrenheit temperature and I want to turn it into Celsius, I want to end up with Celsius, right? So I'm going to use that one that ends or equals the C when I'm all done. And so here I go, plugging in that Fahrenheit temperature in there. This one has this parenthesis quantity. We have to back up and subtract that 32. Oh, I made myself a nice number, didn't I? So just order of operations, simplify inside. And that's just now a 50, isn't it? Well, it'll be a kind of a messy fraction. That's going to be 250 divided by 9. And we could use our calculator to come up with an approximate. Did I do that right? Oh, yeah. Okay. Yeah. And I get, let's call it 27.8 degrees Celsius. That help? Just seeing it again? Is that you, Julia, that asked that? Yeah, whoever. I'm sorry. Hard for me to see who asked that to begin with, but anyway, yes. So did one of those in both directions. I think you'll even see in the 1.10 homework that whichever formula you should use is presented for you in that homework problem. And I give you that on the test too or something like that. All right, is that good enough for that? We'll keep going. We're writing it all down. All right, slow me down. I start erasing before you're ready, and you always just let me know, jump in. All right, our geometric figures, our geometry sections, we've got a couple this term. We do one now, and I think another one near the end of chapter 3. They're opportunities for us, put it that way, to use the processes that we've been practicing. It's kind of like that. The temperature ones there, following order of operations rules. Once I've got numbers plugged into the formula that we get to use, that describes the relationship we're looking for. And kind of like yesterday where I pulled up or mentioned the conversion table that's available in the homework for the unit conversions. There's a geometry formula worksheet, in the formula sheet that's in the homework section for the geometry. Oh, my cat's nervous. I'm going to let her out here. Hang on. Anyway, there's a formula worksheet for this section, and you can print it out or you can download it to your desktop, or whatever form is handiest for you. Come on, kitty, go out. Whatever. So we're dealing with like lengths, like basically in like the concept of perimeter. How far around, if I wanted to say put a fence around an area, or how much molding do I need to get all the way around my kitchen floor, or area, what's the area of that floor, and then how many tiles might I need, something like that, or the area of that field, and then also some volume, right? If I have a container, what's the volume of that container? It's also an opportunity for us to talk about circles, finding the circumference, which is basically the perimeter of a circle, and its area, and the circle formulas, at least the area one, involves some squaring, so we get to use our squaring function feature to do that. So just to start with, we talk about rectangles, right? And in general, right, length, width. Usually we think that the length is longer than the width. Sometimes a problem isn't exactly worded that way and it doesn't matter too much. So just as a concept here, the perimeter, right? You can build a little formula. In fact, we'll see this one again later through the term. The perimeter is just the sum of all the side lengths. So I've got length, width, length, width. I'm going to add up those 4 sides. Now, usually it gets presented as 2 of these plus 2 of those. And just double check and make sure that's what you would see. Yeah, you see that. You would see that on that formula sheet. It looks just very similar to that. So this is a formula. It's a relationship that's been recognized, and it's sort of formalized. If we're ever trying to figure out the perimeter of a rectangle, we can always plug in the length and width and find that total length all the way around. So then I just have to be given those numbers. And so let's say this is say 12 feet, one little line per feet, right? And I'll say this is call it 8 feet for the width. So what is the perimeter of that rectangle? We're going to add it all up, plug it in to the formula. Sort of good process is always to sort of just start with your formula. Next step, plug in the numbers that you know. So in the formula, there's a 2 times whatever the length number is, plus 2 times whatever the width number is. And now I follow my rules for simplifying that expression over there. 24 plus 16, and the perimeter is, that makes that a 40. careful. This whole section now, again, I think mom is nice. Oh, mom, nice to you. It tells you, you know, the units perhaps, but you always have to think about what are the units in an application problem like that? What units are we talking about? And this was all feet. So you can write it in feet, right feet, or the little abbreviation FT. Up here, I just did that little single dash. You know, that's usually what we use for that apostrophe, a single one for feet. There's the basic concept of how we calculate the perimeter of a rectangle. Now, you're gonna see some problems that try to make that a little trickier, right? Here I go, I'm gonna erase. If you have just a basic rectangle, you can use that formula. If you understand the concept though, hopefully you can apply it to something. Maybe you'll see this kind of homework problem. All right, well, what if this is 15 feet and this is 10 feet, and I'm told that this is 3 feet, and I'm told that this is 7 feet. Find the perimeter. How far around is that thing? So the first thing you say is, wait, I don't have all the numbers. Well, there's 10. That means this plus this has to equal 10. Okay. If this is a 3, that means that must be a 7. And that means if this is 15, that means this plus this must equal a 15. So this 15 minus that 7 means there must be 8 left over here. These will always be corners, 90 degrees for this kind of figure, even though it won't be specified like that. So that's sort of the first problem solving aspect of these problems. Oh, I got to figure out what those missing sides are, right? And of course, we're all still feet. Now I'm just adding up all those different sides. Here, it's not that simple formula directly, but here I have, oh, let's say 15 plus 10 plus 7 plus 7 plus 8 plus 3. Just adding up all those side lengths. That's perimeter. How far around is it? If I had to put a fence on it or something like that, how much fencing would I need? And I'm going to cheat here and say, that's 25, oops, it's 50 feet. How did he do that? Now you can add those all up, stick them in your calculator. Here's the little trick, right? What did I do? If it really is a rectangular type figure like this, notice this side and this side and that side, that would have been the same if it was over here and just made a rectangle. So I just said, oh, it's still 2 of these and 2 of these. That's sort of a shortcut, if that makes sense to you. Otherwise, you just add them all up for perimeter. All right. I'm pretty sure, well, there is one like this on your homework. You'll have to do something like that in my open math homework. All right, here we go, erasing. If you have any other kind of irregular shape, maybe it's a triangle, maybe it's just a funny, trapezoid or something like that, and you're trying to find the perimeter, you've got to be given all the side lengths. All right, just got to be told how long each side is, and then you just add them up. That's perimeter. All right. Back to our rectangle. All right. Let's say this is 15 centimeters and this is 12 centimeters. What's the area of this particular rectangle? Area is built on the concept 2 dimensions, right? A perimeter is just a 1-dimensional line all the way around. Area is 2-dimensional, little squares. We imagine, just really abstractly, that, we have squares of a certain unit size, and how many squares are going to fit into this space? That's the area concept. Of course, we try to use the units that are provided. And I don't think you're going to get tricked in this. I say trick, but something to think about. I think you'll find the units are consistent. It's not like we're going to be mixing up units on you at this point. So area for a rectangle it's this length, how many pieces in this direction, times how many am I going to stack up? How many in this direction, right? Or it's length times width. So perimeter and area problems for rectangles often go together. In fact, I think you've got a homework problem just like that. Here's a rectangular figure, it has this length and this width. Find its perimeter and find its area. But again, here's a formula. So I've got the values I need. I'm just going to plug them in. Area is 15 times 12. I kind of know that number. It's 180. Now, units. It's all, area is always something squared. How many little squares? So you can say square centimeters is the units we were talking about in this case, centimeters. Or I could write it with that sort of exponent, centimeters squared like that. It means the same thing, whichever technique you prefer, or even write it all out, you know, square centimeters. Even when we're talking about circles, we assume you can fit little squares in the whole way, and the circle formula sort of takes into account that it's got that curved edge. That's kind of what pi helps us take care of, that number when we get there. But here is you know, a basic formula or area problem for rectangle. Length times width, you know those dimensions. Let's go back to that other one, that other rectangle, something like that. If I've got a figure like this, and let's say what this is was the 15 and this is a 10, and if this was 3 and call that a 7, whatever I made up, doesn't matter. What's the area of that figure? Well, here you've got to basically break it into a couple different parts and find them separately. I could say, oh, let's do that one rectangle and figure out that one, and let's do this rectangle and figure out that one. Another possibility was to think of it as one big one and subtract that piece over there that's like cut out. But you kind of have to problem solve and figure out how best to get what you're after. In this case, I still kind of need those other lengths, right? Well, this one, 10 times 3, there's basically two areas I'm going to add together. I'm going to do this 10 times 3 plus this area, right? Well, let's see. This isn't, what's that side? I need to know that side, right? So this was total was 15, and I took off this 3. So that leaves 12. A little different than the first one I drew, right? So that one's going to be 12 times 7. Everybody okay with those numbers? How I got those numbers? Let me know if I lost you there. So the area of this figure is just the sum really of two separate pieces. Put them together. This one's 30, and what's that? 84. For 114. And oh, I didn't give you units. Let's put feet on there, okay? I need to give you units, square feet. Square somethings, square feet. Okay? Your regular rectangular shape, then you've got to break it into different pieces. Here we go, on to the next. Stick with area for a while. Triangle. All right, draw a couple triangles here, but sort of talk about where we come up with this formula. Imagine, you know, if I sort of doubled it on itself, it'd be a rectangle, and that area would be length times width if it was that rectangle. And notice how the diagonal that I've drawn here cuts it in half. So the area of the triangle is half of that rectangle. Now, for a triangle, it turns out that formula applies to any triangle. All right, doesn't have to be one that looks like a nice, right angle in there. As long as you consider like the length, here is the base. All right, and the width over here is the height. And here the height is that sort of perpendicular from that other corner straight down to your base. So we need to know the base and the height of our triangle. And if it happens to be one that, is like cut out of a rectangle like that, well, one side's the base and the other side is your height. But our formula then usually, and I'm gonna do a little eraser math now, right? We usually say 1/2 the base, base times the height. 1/2 the base times the height is the formula for the area of a triangle. So now we need our dimensions. We need to know those figures. Let's say the base is 20 inches and the height is 8 inches, just making up some numbers. You get to use your calculator, so if they get a little messy, hopefully your calculator will help you through that, or do it in the best way you'd like to do that. Plugging the numbers in now. So, excuse me, the area is 1/2, my base is 20 times the 8. And there I'm ready to multiply those together. You remember a commutative property, you can do this kind of any order you want. I could say, 20 times 8, that's 160, and half of that, or half of 20, that's 10. So 10 times 80, excuse me, 10 times 8, getting ahead of myself, 80. And I called this one inches. It's still, imagining little square units squeezed in. So it's square inches, or inches squared, if you want to write it like that. You've got a formula to work with. You plug the numbers in appropriately and then simplify your expression. All right. Couple more areas, okay? There we go. Triangles all work like that. I'll just say, even if it looks like this is kind of weird, right? Yeah. What if my triangle looks like that and I'm told this is the base? Where's my height? Well, maybe you know this. That could be well, that's not the base over there. So really, the height's got to be relative to the base. So you actually have to be told, if I imagine a right angle over here, what would that height there be? So if it's oriented strangely like this, you've got to be given that height is that perpendicular to this base. So you have to imagine it's extended so you can go straight up to that other corner. It should be done correctly for you, presented correctly. I'm not trying to get you to do anything real tricky yet. We hope not, right? And how about this one? This figure is called a trapezoid. Right, a trapezoid has one pair of parallel sides. Sometimes they look, like that. Here's my parallels, right? And so these two sides are referred to as the bases usually, like this is base 1 and base 2. Well, the two parallel sides, right? And then we still need to know the height. And then we have a formula, right? A formula for the area of a trapezoid. 1/2 the height times the sum of the bases. That's kind of weird. There's kind of a long explanation you can go through to how you can kind of chop it up and make a couple rectangles out of it, and that's how you can, and then simplify that formula and to come up with this formula. But we need 3 numbers now, right? I need a 10 here, call it feet, and I'll call that an 8 there, call it feet, and I'll call that a 5. Okay? Making myself nice numbers for the board work here. So I need to know those 3 dimensions, and I'll plug them into the formula. 1/2 times the height was 5, and base 1 was 10, plus base 2 is 8. Now here we do have some order of operations. That is, a grouping. Let's simplify in there first. 1/2 times 5 times 18. Here's a time I actually am going to use sort of that commutative property and say, I'm going to do 1/2 to 18 first. 1/2 of the 18 and get 9 times 5. All right. Kind of mentally just moved them around. And still something squared. This was all feet. So square feet. Bunch of little squares inside. This whole section is based on a formula that you're given, and plug in the numbers into the formula to come up with the value we're looking for. Trapezoid's a little weird like that. Funny looking formula. Okay. Circles. All right. Ooh, pretty good one, Steve. First one of the year here. All right, here we have our circle. And a line through the center out to the edges. So this is the diameter. All right, how far across the entire circle? Half that distance, or from the center out to the edge, that's the radius. All right, a couple terms that we use when we talk about circles. Okay, how far around the outside of the circle? Well, I mentioned this the other day when I was talking about that irrational number pi. Circumference, instead of the word perimeter, we use the term circumference. I think I spelled that correctly, circumference. Maybe there's not an extra E, but oh well. Sorry about that. Circumference, well, the circumference is related to the diameter, all right? This is where I did that little demonstration the other day where it's a little more than 3 times the diameter around. Specifically, it's that number pi. 3.1415 forever and ever, doing a bunch of stuff, times the diameter. That's the circumference of a circle. So if you know the diameter, you plug it in. I think you can get away with Martinich Math using 3.14. But whoop, there is a pi button on your calculator somewhere. And it includes lots of decimal places. Yeah, I'm looking at one of these, little ones like this, which are, just perfect for this class. And there's a button on the left-hand column that says pi. But like I said, I think that level of accuracy would be fine for what we're doing. Notice also the diameter is twice the radius. So I could replace the D. If I know the radius, right, I'm going to have to double it. So another version is pi times twice the radius. And you usually see it in that order, 2 pi r, the way that formula is usually presented. But the 2 times the r is the diameter. So these really are doing the same thing, depending on what number you have to start with. So let's make up one and say, this one is, say, 7 feet. That diameter is 7 feet. So my circumference will be pi times 7. Circumference, just the length. All right, just the length. Pi times 7. $21.999. And really, I have 991 and a bunch of other decimals. if I recall, well, I think mom's pretty good about telling you around someplace. Here I might just say that's approximately 22, and this was just a length, so it was 22 feet. Not an area, right? Not little squares, just how long. Putting a string or tape measure around the outside. So again, you've got those two, and I bet they're both yes. Well, on your formula sheet, actually, they present as 2 pi r, but the 2 r is the diameter. So you put that in your notes. You can use either version, whatever information you're given to start with. Plug in those numbers in, and then simplify that expression. Is that all right? Circumference. Use the formula. I'm going to continue with the area for a circle. All right. So here I go. Now, I keep saying, oh yeah, we imagine little squares. All right. Well, how do you get little squares around the curved edge? Well, the derivation of this area formula is much more complicated math. Kind of got to do calculus to come up with how they generate this formula. But it's based on the radius, like the square of the radius. Gee, if I square the radius, and I get this little square, it's pi times that square. How many of those squares fit into this? Pi times the radius squared. Pi r squared. You hear the joke, pi r rounded. Haha. Okay, area is pi times the radius squared. Notice this is just squaring the radius, not pi times the radius and then square. If we wanted to do that, we'd have to put those together in parentheses. So just the radius number is going to get squared. And that'll tell us then the area of that circle. So let's get rid of some of my other junk in here, right? Back up again. And let's say I know this radius is, say, 5 feet. That radius is 5 feet. Plugging it into the formula. The area is pi times 5 squared. Now you can type that exactly like that into your calculator. Again, nice little thing if you're working with something similar to this. Again, on mine over here on the left-hand side, yeah, I mentioned there's a little pi button right over there. There's also one that says x squared button. If I type a number and then push that button, it automatically squares it for me. You might try that. It's kind of like a shortcut, right? Otherwise, I have to do 5 times 5. All right, but I can type that right into my calculator. I can push my, whoops, clear it up, pi times 5, and then I use that squared button. It even looks like that on my calculator screen. And I get this number 78.5 and more decimal places. And it is an area, so it's square units, and we were starting in feet there. So square feet. Using the formula, you need to know the radius. Now, some of these problems might present you with the diameter of your circle. Right? If you know the diameter of your circle and you're trying to figure out its area, you need to cut that diameter in half yourself to come up with the radius value. We'll do another one just for that reason, okay? Let's say I know the diameter here is 12 inches. Know the diameter is 12 inches. I want to find the area of that circle. That's pretty close to that, isn't it? The area is pi times, well, radius is half of that. 6. If it's a messy number, use your calculator, whatever. 6 squared. I had to figure out what the radius was. So now I'm going to put that in my calculator. Pi times 6 squared And this one. And what did I do? I did inches squared that time. 113.1 approximately. Anytime we're using pi, it's never going to be an exact answer because pi isn't an exact rational number, right? It's that irrational decimal goes on forever. So we always have to estimate around our answer. Hopefully you'll get instructions as to how many places to round. If I'm writing a test, I am always careful about that. In MOM, the tests are generated by the program, although we tell them what kind of questions to put in there. But if you put in, we figured out if you put in 1 or 2 decimals correctly, you're going to be fine in terms of MOM. It will accept that answer. Is that okay for the circle area? I'm going to keep going. All right. So volume. All right. Perimeter was 1 dimension, a length. Area are 2 dimension, little squares. Volumes are like little cubes all over everything. Checking our time, good. My 3-dimensional drawing here. All right, that's supposed to be like a box, look like 3-dimensional shape, a box. All right. And so volume imagines that we've got a bunch of tiny little cubes inside there. How many cubes can we stack up to figure out the volume? So, oops, volume formula kind of starts with the area part of it, right? Length and width, length times width times how tall is it? Times the height. We need 3 dimensions. We need 3 numbers to multiply together to get a cubed something. Your units for volume will always be something cubed. That's the word we use for the exponent 3, right? Hopefully at least that wasn't too much of a surprise there. So let's say, all right, I need to know these numbers. So the length, I'm just going to say 15 feet, and the width is 8 feet, and the height is 10 feet. I need to know those numbers. I need to know all 3 values, and I'll plug them in. So my volume is 15 times 8 times 10. And, let's see, 8 times 1.5, that's, but I don't want to make a dumb mistake here. I think it's, I've done enough of those already. Plug it in your calculator. 15 times 8 times 10, 1,200 feet cubed or cubic feet. For dimensions like this, we don't have a 4th dimensional shape, so we use square and cube. For 2 and 3 as the exponents. All right, so you can write it either way. So volume of a rectangular solid, we would call this. We have a few more weird ones. All right. Okay. So this basic rectangular solid, here's your formula for that. You need all 3 numbers. You'll see a couple of these on your formula sheet. Let's see if I can make it look reasonable.
Are we going to be allowed to use our formula sheet like during the test at all?
Well, yes, right. You're at home taking your test. I'm pretty sure the formulas you'll need for a problem are included in the test question. Okay.
Okay, thank you.
Yep. Good question. All right. And let's see if I can almost draw this. Supposed to look like a pyramid, okay? Kind of a pyramid. And again, working off your formula sheet, volume is kind of unusual. 1/3 the base times the height. Now, when we're talking about talking about a pyramid, Now the base is that bottom there, and that's really a length times a width, but we'll always be presented with basically a square base. So the base is going to be those two numbers, and then your height, I'm imagining it going up through the middle, right, to some point right in the middle of that. So you've got to be given those dimensions, and then you can put the numbers in there. Now maybe you'll be told an area for that base, but you're really calculating the area of that base, all right? So let me make up, I'm going to call that 5, which means that's always going to be 5. Problems we're going to give you, they're all going to be square-based pyramids. And let's call this 7 up here, okay? And we'll call it feet. Make them all feet. Units, obviously you need units. So this is going to be 1/3, and really my base, just for emphasis, I'm putting in parentheses, is 5 times 5 times the height here. Whoops, height was 7. All right. Now, lots of times you can interpret a volume as, gee, a base area times how tall it is. Well, the pyramid is the base area times 1/3 of how tall it is, like we've chopped off 2/3 from all around the outside for a pyramid. And so 1/3 times 25 times 7. Now, if I want to plug that in my calculator, you can do 1 divided by 3 times 25 times 7, or really 1 times 25 times 7, and then divide by 3. The fraction, the number in the denominator is like a number you're going to divide by. Convenient to think of it that way in your calculator. So I'm gonna say 25 times 7 divided by 3. Just straight row like that. Then enter, and I get 58.3 repeating, and I did feet, so this will be cubic feet, feet cubed, 58.3 cubic feet. Using the formula, thing about the base of a pyramid is that you do have to kind of do the length times width yourself there. Now it's interesting, I think, mathematician, haha, if I have a cone, all right, there's my height. That's a circle with a radius. And our formula for that volume is, again, the 1/3 pi r squared. Remember, that's the area of the circle. That's the base area. Just like this was the base area. That's the area of the circle times the height. I think that's kind of weird that you've got a square-based pyramid, and here you've got a circle-based cone, and the formula is really closely related. It's the area of that base times 1/3 times the height. So for a cone volume, again, we're still talking about volume. How much is in that snow cone, whatever. And let's give us some numbers. So let's call this 8 inches, and we'll call that 4 inches. Okay, radius. If I know the diameter, I have to cut it in half and find the radius. So 1/3 times pi times 4 squared times 8. It's only that radius number that gets squared. 4 times 4 and not anything else around it. That's a error some folks make. Good, I've got to wrap this up. I like to talk about the homework problems usually at this section. Here we go, clear. So I'm gonna save the divide by 3 until the end, like I did before. Here's my pi times 4 squared, I use that square button again, times 8 divided by 3, and I've got 134.0, and what did I do? Inches cubed. Plug them into the formula. Perimeter is length for one dimension. Area is squares, right? Something squared, and volume is something cubed. Watch out for that on your units. If you're looking at that formula sheet that gets printed from mom, there are some other things called SA. What's the SA? Surface area. Like if I had a shoebox or a room, how much paint, I need to know the surface area. It's really like adding up the areas of all the walls. We're not asking you to do that right now, but if you see that on that formula sheet, I just wanted to mention it so it doesn't confuse you. We're not using the surface area. So now the homework problems. Now I have my version of them in front of me for this homework section. I just like to talk about the problems a little bit. You want to maybe make your own notes as I go through this. Question 1, find the perimeter and area of a rectangle, and you're given the dimensions. So it's just like my first example. You've got a basic rectangle and you're going to find the perimeter and the area. I hope that one feels straightforward about. Question 2 is find the area of a triangle. And again, you're given the base and the height, and you find that dimension, all right? And it starts getting into a little more like problem solving, word problem-ish. Number 3, mine tells me you have a sprinkler. Mine tells me it's a sprinkler and it covers a circle with a diameter of 28 feet. What's the area that the sprinkler covers? Oh, so I got to use my area formula. Means I'm going to need the radius. I'm going to have to cut that diameter in half. But it's an application of circle's area, the area of a circle. Number 4 is one of those things. Find the perimeter and the area, and they give you just enough numbers to do that. Actually, number 5 is the same kind of thing. Gives you another one of those things. All right. Now, question 6. Mine looks like this. It's a rectangle with a triangle on top, and you're supposed to find the area. So I've got 2, and you're given all the numbers you need, but I've got 2 different shapes. I have to find the area of the rectangle and add it to the area of the triangle. Just put the 2 together. Okay. 7. Maybe the messiest, not trickiest. Here's a circle, and there's 2 little circles inside of it. And they tell you what this diameter is here. And so there's several parts. What's the area of the big circle? So if that's your radius, you can figure out the area of the big circle. They ask you then, what's the area of the 2 little circles? I wish it was more clear, but they want you to find the area of the 2 circles. They're identical, and you add them together. You add them together, so 2 times whatever you come up with. And then they say, well, what's the area of the shaded part? Take the big circle area and subtract the 2 little circles. So I like to talk about that usually. All right, last couple are very similar to each other. Let's see, I think they're the last couple. Sorry if I'm time-wise, I'm good, I think. Mine, again, your problems will have different numbers, but it should be the same kind of problem. A unicycle, all right, a wheel. And they tell you the diameter of that wheel. And then they say, if that wheel rolls a certain number of times down the road, how far did you go? What are we using here? How long is that length related to this wheel? You would just want to figure out what's the circumference of my wheel, right? How far around once around the wheel. And then if I roll 10 times, it's 10 times that circumference. Okay. Which question were we talking about? 8, I think, right? Is that the right number? Just trying to help you out with that, yeah. So it's a circumference problem, and then the extra step of multiply times how many times. 9 is the same kind. I've got a rope and it's coiled up a bunch of times. How long is the rope? If I tell you the diameter of the coil, well, I figure out from the diameter, I can figure out the circumference or once around the loop, and then it tells me how many loops. It's a circumference problem again. All right, those two. 11, oh, 10, oh. Oh, 10's probably the trickiest one, okay? Just because of units. Watch out for units, make yourself a note. Watch out for the units, number 10. How many rolls of wallpaper? Each roll of wallpaper, mine says it's 9 yards long and 18 inches wide. And the room is, let's see, oh, the sides of a room, oh, 4 walls. I got 4 walls, right? I'm gonna draw, there's my side wall, right? I got 2 walls like this and I got 2 walls like that. I showed you half of my room, right? There'd be 2 more walls. Mine says I've got, what, 15.2 and 14.4, and those are, oh, let's see, feet, and let's see, 8 feet walls, 8-foot walls. Can you break this down, figure out how you're going to figure out? First, I need to figure out what the area of my walls is, right? So this really is kind of like a surface area problem, although it wasn't presented that way. Sorry. Right, 14.4 times 8 tells me the side wall, but I got 2 of those, so times 2. 15.2 times 8 tells me the big wall. I have 2 of those, right? So times 2. The problem goes on to say, and then subtract a number. It just tells you how much. Subtract some for the door and the window. So whatever big number you come up with, then you're going to subtract. Well, how many rolls of paper? Well, what's the area of 1 roll of paper? Here's where you're going to watch your units. This is all feet, right? Feet, 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 feet. I'm going to come up with square feet. This is yards. This is inches. I would change those all to feet. Now mine said 18 inches, so I would say 1.5 feet. You can divide by 12, right? Use a conversion if you need it. But divide by 12, I get 1.5 feet. 9 yards, a yard is 3 feet. 3 times 9, that'd be 27. So I'd be doing 27, I'll just do my example, right? 27 feet times 1.5 feet, and that would tell me the area of 1 roll. How do I figure out how many rolls? Take my total area minus the doors, right? And divide by the roll area. See if that concept makes sense, right? How many rolls do I need to cover the wall? Take my total and divide it by how much is in 1. And hopefully it tells you to round to something. Or actually, you need the whole extra roll, right? I can't only buy half a roll. That's that kind of question. I can't buy half a roll, so how many rolls do I need to buy? I need to buy the whole roll to do the last decimal part. Well, I have to eat my words here. I'm looking ahead, and there is a surface area question. A surface area question of a rectangular solid, basically a shoebox, kind of like this. Find the surface of all the sides and add them together. And that's just length times width of each side, the surface area. Add up all the sides. One last thing before I'm really out of time here. I didn't talk about this volume shape. kind of got ahead of myself. A cylinder, right? A can. All right. Based on really a similar idea to what I've been describing, the area of the circle times its height. So we'll need to know the height. We'll need to know the radius. Pi r squared, the area of the circular end, times its height, and that'll get you the volume. Just square the radius, but you're going to plug numbers into the volume, and that's on your that's on your formula sheet. Give those all a try. They take a little more thought and time, perhaps, than some of our other homework. So I give yourself time to do that. Don't wait till the last minute. I always say that, right? And of course, it's Thursday, our last class of the week, but I'll be around and checking in all weekend, and send me questions if you get stuck. All right? So that's it for today. And I'll keep an eye out for you. All right? So I hope you have a nice weekend, and keep those questions coming, and some posts and so on in the forum. Help each other out. Thanks again, Sasha. She found a chart from text that helps lots of folks. Whatever works. Okay. All right, guys. See you Monday. All right.
Thank you.
Monday.
Thank you.
You're welcome. All right. See ya.